Think of a circuit as a little society in PCB or printed circuit board. A printed circuit board, such as shown in the picture, contains components that have their respective functions to make a device work. In the same manner, the architects use blueprints to arrange their design plans. The layout of a circuit can also be planned using a circuit diagram. It enables us to clearly and accurately represent the circuit so that we can analyze its inputs and outputs. In this lesson, you will learn the different components and the ways to correctly represent them in different circuits using schematics. In the previous lessons, we have learned various concepts about electricity, such as voltage, resistance, and current, and applied them in analysis of simple circuits. These concepts will play a great role in helping us to understand the process of constructing more complex circuits in this discussion. Before that, we will define first what is a circuitry. It is a system of circuits that can be described verbally or diagrammatically. We have mostly done so using words in the previous lessons. Another way to characterize a circuit is through the use of drawings, pictures, or diagrams, which are in a phase of a great way for us to have a clearer picture of how the actual circuits they correspond to look like. As we continue, here are some important terminologies that you need to understand and remember. First, a circuit, from the words circle or circular, refers to the system of components, power, and signal sources that enable the current to flow around. We have two types of circuit, an open and a closed circuit. A closed circuit implies that the circuit is complete and current can freely go around. An open circuit, on the other hand, implies that the circuit is incomplete and there is a gap somewhere in the path. When illustrating diagrams, we have to take note of the common symbols we use to represent the components. First on our list is a bulb. We use bulbs in our circuits to identify whether the circuit is working when we connect it to a power supply. In symbol, we represent it as this. Next is a cell, or a direct current voltage source. Of course, it supplies a low voltage electric current in the circuit. In symbol, we represent cell as this. Do not be confused cell with a battery, as a battery is made by joining two or more cells together. If we represent these, we combine two cells in series. It will not be much of a circuit without a connecting wire. These connecting wires allow current to flow through from one point to another. We can represent this as a straight line. Capacitor, which we had in the previous module, is a two-terminal electrical component for energy storage. We can use either of these two schematic diagrams, depending on the type of capacitor that we will use in the circuit. Next is a resistor. This component controls and regulates the flow of current. In symbol, we represent it as this. Another important component in our circuit is a diode. This allows an electric current to flow in one direction while stopping it in the other direction. A schematic diagram of a diode varies depending on its type, but we can use this symbol to represent a standard diode. We also have a transistor. This component amplifies or switches electronic signals and power. In symbol, we can represent transistor as this. Another one is an inductor, which resists alternating current while permitting direct current to pass. Its representation in circuitry is like this. Then we have the logic gates, which represent logical functions or decisions in your circuit. We have 6 types and they are represented differently based on their function. We have NAND gate, we have NOR gate, AND gate, OR gate, XOR gate, and NOT gate. We cannot forget, of course, is the switch, which turns the flow of electricity on and off. If the switch is represented as this, it is off, and you see a gap between the two connections, signifying current will not move. On the other hand, if the switch is represented as this, it means it is on. We often see this representation as well in our circuits. This represents a transformer. It trades voltage for current or current for voltage. This is used to change a small alternating current to a larger one or vice versa. An ammeter, which we represent as this, is a device used to measure current in a circuit, whereas a voltmeter, which is symbolized as this, is a device used to measure the voltage or potential difference. The last set of illustration we have is for schematic wire junctions. Here, we will enumerate the symbols for wires, cables, and connectors in an electric circuit diagram. First, if you see two wires crossing each other, the point of connection has a small solid dot. This means that the wires are connected and the current will flow once the circuit is open. If there is none, like this, it means that there is no connection. Another way to represent no connection is when a horizontal wire hops over the vertical. Lastly, if we see double junctions as these, this means that the wire have two crossing wires joined with one another. In the next video, we will apply these symbols and basic concept in constructing circuit diagrams. But that is all for this lecture. I am Gilmar De Castro, and see you in the next video.